So I want to show you guys my over-engineered setup. I just feel like the last generation of models can't be left alone to do normal development tasks. Basically, they've been so RL fried to do long horizon tasks that if you just try to have it do a refactor or a change or something like that, it's gonna go beyond its scope. And so I have basically had to over-engineer some sort of personal approval tool. Just because here's my gripe. The first generation of approval tools, just like plan mode and approve this, approve for the session, they don't work anymore, right? The models are good enough to not do code changes, but they're not good enough to stay within their scope. And they make so many changes that you can't approve every single file edit. So what I came up with was this sort of local workbench app, and it hooks into all of my codex instances. And so here we have the request log. These are all of the tool calls. And then on the right here, we actually have something interesting where these are not just the diffs, these are the AST compressed diffs. So instead, and I could see the full diff if I want to, right? But instead, I could actually just see the sort of top level call graph here. And that just lets me understand, is the model on the right path? Is it not? And then you can just see some request details, things like that. I also have the actual codex thread here so that I can quickly see if I'm running a bunch of different tasks, see where this is coming from, what the context is. You also see that I have these scopes as well. And so these scopes are kind of interesting. Let's see if I could trigger something here. I have a thread or two working on, well, so here's something interesting here. Great. So I have some shortcuts here. Allow the scope for 5 minutes. So the scope here is, this requested scope is harness. And so the way that this actually works is that the different parts of, I've divided my code base into different parts. There's different levels of docs. There is the actual code, UI stuff, backend stuff, contract stuff. There is, this in particular is the actual integration test harness. There's end-to-end harnesses as well. The idea behind this is that usually for a thread scope, I'll know which part of the code base the thread should be working on. And so for instance, sometimes I'll be working on code changes, sometimes I'll be working on spec improvements, sometimes I'll be working on testing. Very rarely should a thread actually be doing all of those at the same time. I think today you really need to have some serious layering that goes on with your code, because if you don't, you're just going to end up with just absolute slop. It's just not going to work. And so this requested scope is code. I also have these shortcuts here, which are sent to the model directly, not only as tool denial feedback, but also steering as well, because I find that that actually works better. And so these are just sort of skills that I have of common feedback I have for the model: wrong, better way, why are you doing this, overspecified, make it concise, and focus, especially when it's off task. And so this just allows me to get a first pass at the code as it's coming in before it gets too crazy. I find that you have to, I've found that if you are waiting to the pull request to actually do the review, or if you're waiting for the model to be done to do the review, it's already too late. You actually need every single line of defense against AI generated code. So you need pre-tool use, you need local review, you need agent review, you need review before you send it to your teammates, you need review after you send it to your teammates. Oh, the other thing that I've also done is that tasks are also separated out as their own scope. So actually, I should bring up the approval system and how this actually works, because I think that's kind of interesting, kind of cool. Let's see. So this is my agent approval system. So the way that it works is that instead of it being static like Claude hooks or Codex's Starlark rules, the Starlark rules they're okay. You could really only do prefix rules though, so it's not super useful. So I thought, why not actually just describe it in just plain old JavaScript, have it invoked via V8, and it's quick, it's portable, and you can basically do any sort of rule that you want. So I have all types of stuff here. It's pretty long. Nothing that can modify git locks, no work trees, no maintenance on the actual Git repository. Let's see. Things like whitelisting, some AWS read-only commands, but asking for approval for, actually, I deny pretty much any modifying AWS commands, and then I force everything to go through the monorepo's task system. And so that's really good. And then it's also restricted. You can't be sending custom environment variables or custom flags into the task system. And this basically lets the agent have a very constrained surface to deal with. Basically, these are all the guardrails that I've had to do to actually just make sure that there's no slop or minimal slop in the repository, right? There's just so much code coming in and going out that I think you need stronger guardrails than these harnesses actually let you have. And so these are just invoked via pre-tool use and post-tool use. We get some information about things as well. Hopefully this data will be useful at some point for L or whatever we're collecting. I've probably collected millions of command invocations in the last week. And then I could also feed that back into the model to understand, because we also have command timing. We can see what commands the model consistently fails with, which commands actually take a long time, and sort of there's probably some n-gram analysis or something like that of what sequences of commands the model often does so that we could potentially collapse them into something else. So that's the setup. That's part of what I've been doing to deslopify. I think maybe another day I'll go over the sort of rigorous linting and code quality programs that I have around my code in my monorepo. I think basically one thing that I've found that you have to do is you need to take the lint rules to the absolute extreme, to the point where I would say that the agent is only allowed to write a very small subset of the language. And I think this is a principle that gets you pretty far no matter what you're doing. For me, I've been working on some math proofs in the background and using this lean harness that I've created. And basically the agent writes a very small subset of things that compile to lean, and I've found that that is much better than just giving it unconstrained programming language access. And that's the same for TypeScript, Rust, and that's the system. And so that's just part of the system. That's really not even scratching the surface of what I've had to do here to make sure that the code quality is at least a B-.